In this video, we're going to talk about the dot product of two vectors, the geometric vectors and algebraic vectors. The dot product of two vectors is a product that results in a scalar. The dot product will be the magnitude of A times the magnitude of B times the cosine ratio of the angle between the two vectors. Why cosine? Because the projection of A is involved, the adjacent side and the hypotenuse A, which provides us the ratio of cosine. So this is the formula for the geometric vectors dot product. If we have A dot B and we're able to calculate the magnitude of A and the magnitude of B, and we know the angle theta between the two vectors, we can determine the dot product of the two vectors. Now from here, we can also isolate for theta. Theta is equal to cosine inverse of A dot B over the magnitude of A times the magnitude of B. When the two vectors are given to you in their component form, either in 2D or 3D, the formula for the dot product will be based on the components of the two vectors. Given the vector A with components, for example, 1, 3, 5, and vector B with components -2, 1, 0, we want to determine the dot product of the two vectors. The dot product given components will look like this. A dot B is equal to 1 times -2, components 1, plus 3 times 1, components 2, and plus 5 times 0, components 3. Therefore, A dot B is equal to -2 plus 3 plus 0. A dot B is equal to +1. So 1 is a scalar quantity, it's not a vector. Remember that. Now let's discuss some properties of the dot product. For example, if I know that the dot product of two vectors is equal to +2, since the value of the dot product is positive, it means that the angle theta between A and B is a positive acute angle. If the dot product of the two vectors is a negative value, then we know that the angle between A and B is obtuse. Next, if the dot product of the two vectors is equal to 0, then we know that A is perpendicular to B, and we also call these vectors orthogonal vectors, which means perpendicular. When you do the dot product of the vector on itself, then it's equal to the magnitude of that vector squared. You can also use the distributive property on the dot product. For example, you could have A dot B plus C, and that is the same as A dot B plus A dot C, where A dot B and A dot C is the dot product between the vectors. This will result in a scalar quantity, this will result in a scalar quantity, and then you add the two scalars. Say we're given two vectors. Vector A has the components of 3, -2, 4, and vector B has the components of 5, -1, -2. We want to determine the angle between the two vectors, and in order for us to do that, we'll have to use, so we want to know theta, and we'll have to use the formula for the dot product that involves the angle, the magnitude of A times the magnitude of B times the cosine of the angle. Now, in order to determine the magnitude of the vector, given its components, we need to use the distance formula. So the magnitude of A will equal to square root of component 1 squared plus component 2 squared plus component 3 squared. So the magnitude of A is equal to square root of 29. Let's repeat the same thing for the magnitude of B. The magnitude of B is equal to square root of 5 squared plus -1 squared plus -2 squared. And the magnitude of B is equal to square root of 30. Now let's find the dot product of A and B. A dot B is equal to 3 times 5 plus -2 times -1 plus 4 times -2. A dot B is equal to 15 plus 2 minus 8. A dot B is equal to 9. Now we have all the pieces that we need in order to solve for theta. Let's rearrange for theta and solve for it. So theta is equal to cos inverse of A dot B over the magnitude of A times the magnitude of B. So then theta is equal to cos inverse of 9 over square root of 29 times square root of 30. Theta is equal to approximately 72 degrees, and it does make sense because the dot product of the two vectors that we got was a positive value. Therefore, we anticipated the angle to be an acute angle, less than 90 degrees, and it is.